All right, this is 3.07 in physics, part 2. So we've got another sample problem. We've got Reese Verhoef's going to punt the football, and he's punting it 1 meter off the ground at 20 meters per second in a 37-degree angle. How far away does the football strike the ground? Well, this time we're not starting for all of our other problems, or the other problems that we looked at. We start at the same level that we end at the same level we started from. So what happens if we have a difference in height? Well, we can handle that. Let's start off with a diagram. All right, let's give Reese a football helmet, face guard, and pull the ball out, kicking it, one leg, and this is 1 meter. So we're going to make the ground our 0. And he's punting it at 1 meter, and we're going to punt, and we're going to land. That's a really bad diagram, but you know me in drawing. All right, so let's take a look at our kinematic variables. We've got x, x, t. This has got a vector of 20 meters per second and 37-degree angle. So 20 meter per second, and we've got a 37-degree angle. So I have to split this out. I have to split this into Vx and into Vy. So Vx is going to be 20 cosine 37, and when I do that, I get 16 meters per second. And I go into my vertical variables. Remember, they live separate lives. I've got an initial y, I've got a final y. I have got initial y velocity, a final y velocity, an initial y position, a final y position, acceleration and time, and as always, let's say I'm using a standard coordinate system. Well, I'm starting at 1. My acceleration is going to be negative 9.81 in the vertical. And when I resolve this vector, so I'm going to do 20 meters per second times sine 37. This is going to be 12 meters per second. So what I need to do is I have to solve for time over here, and then I can bring it over here. So the equation that's going to work best for me is y sub f equals y sub o plus v sub o t plus 1/2 a t squared. Y sub f, oh, yep, I forgot to put that. I'm like, where's my variable? So we're landing at the 0 point. All right, when I plug in my variables, I end up with 0 equals 1 plus 12.04 t plus 1/2 negative 9.81 t squared. This becomes, so if I flip this around and I put it into a quadratic, I get negative 4.91 t squared plus 12.04 t plus 1 equals 0. Now you can do one of two things here. You can Google how to program the quadratic equation into my TI-84 calculator. Actually, you can do 3 things. You can Google find a quadratic equation calculator, or you can do a roundabout. So I want to talk about the answer. Let's say I actually Googled quadratic equation calculator because I didn't want to program it in. So when I solve this for quadratic equation, I get that t equals, you always get 2 values. So one of the values is negative 0.081 seconds, and the other one is 2.53 seconds. Well, this doesn't make any sense. This guy gets tossed out. So our answer is 2.53, which I'm going to bring up here. I know that my velocity is distance divided by time. So I'm going to have 16 is x over 2.53. And when I solve, I find out that my displacement is 40.5 meters. Well, what if you didn't want to use the quadratic equation? The workaround takes a while, and I'm only going to talk about it qualitatively. I'm not going to do all of the algebra for it. So let's say we didn't want to use the quadratic equation. So I'm starting here, and I've got so I'm looking for my range. This is called the range. I would have to divide this into two. I would have to find t for this side, and I would want to find t for this side and add them together. But when I get to this second part, so the first is pretty easy because I can do, for this side, I can do t, I can do v sub f equals v sub o plus at, and I can find this pretty fast. But to get this, I don't have enough kinematic variables. So in order to do this, I have to also solve for y sub final on this side. So I have to do this, and then I have to solve for y sub final. Now I have enough variables to solve for time on this side. So I have to do that third calculation. And then I can add my times up to get my total time. And I can finally do this last piece. So I'm not a fan of quadratic equation, but sometimes it's just faster. I try to stay away from those problems on the test. I don't want to put you in that situation because maybe you didn't program it into your calculator. But usually if you're going to leave from a height or end at a specific height, you have to either do this long workaround or you have to do a quadratic function. You can pick. Let's see, I don't know how I'm doing on time for this guy. I'm gonna pause it for a second. If you're not going to take the AP test and you know you're not going to take the AP test, you can stop now. But I have kind of a shortcut for you. It's called the range equation, and I might as well just tack that on to the end of this video. Range equation. What they do is they take the kinematic variables. And so if you are starting and stopping from the same point, so the criteria for the range equation is you have to start and stop from the same point. So your y initial has to equal your y final. But if you're launched from an angle, you can use this without breaking down your velocities. And the equation is that the range of a projectile is equal to its initial velocity squared. And that's 20. That's not breaking it down. Times the sine of 2 times the angle it's launched at, divided by acceleration due to gravity. So in this case, let's say we had let's say he was punting off the ground, and this wasn't at the 1 meter mark. I would have taken 20 squared times the sine of 2 times 37 divided by 9.81, and that would give me the range. Now, this isn't something, it doesn't show up on the AP formula sheet, but it can be programmed into your calculator, and it provides for a really quick range calculation. So this is range is the distance. Horizontal distance traveled. So it's a really nice shortcut. Again, AP testers, I would recommend getting this plugged in. It can actually help you on your chapter test you take next week, because you can do a really quick check. Did I calculate, did I do my calculations correctly? Okay, so if you want another one, if you want a part 3, I will record it. You just have to let me know, shoot me an email, and that's all for now. Thanks for watching. Have a good day.